So this is another example. It says the data in the frequency table below shows the probabilities for the location a person was sitting in a plane during plane crashes and whether they lived or died. Are the events a randomly selected person is in a plane crash? Sorry, are the events a randomly selected person in a plane crash was in the back third of the plane? And a randomly selected person in a plane crash lived? Independent events. So we're trying to see if there's some sort of correlation between like where you sit on a plane and if you lived or died in a plane crash. So first off, we're already kind of in a conditional probability because we're only looking at people in a plane crash, but that's not really what we think of as our condition. That's just the only data that was collected. The total data was from people who had been in a plane crash. So to start this, I'm going to pick one because we know it doesn't matter which one I picked. So I'm going to start with the first thing that was mentioned. So yes, this is kind of weird because we have three options here. So technically both of these are B prime, but that doesn't really matter because I'm not really doing anything with that. So don't worry about it, just pick a letter for the thing you want to work with. We're going to do a B, and then we're going to do an A here. So if I pick B as what I want to find the probability of, you'll notice quickly here that these are a probability table versus numbers table, but that's totally fine. I can still calculate at the same time. So what's nice is I can set up a fraction, right? So B over the total, but since it's already probabilities, so I divided these two, we don't really have to do that, right? I could just use the 0.33. In contrast though, when I do my B given A, to make this independence test, I'm in the A row, I do have to divide two numbers because this total number is not just one. So I'm dividing these two, 0.226 out of 0.636. So I'm going to take those two in and just see what happens. So 0.226 divided by 0.636. And I do get 0.355. Okay? So if I just look at the people that are alive, there's a little more chance that they were in the back third of the plane, maybe versus another part of the plane. So we would say being in back third of the plane. And I do not need to write a third on that. And living are not independent events. P of B was not equal to P of B given A. So we're going to look, and there's actually another pattern that forms with independent events, and we're going to look at that now. So it says, recall the conditional probability formula from last lesson. So this is P of A given B equals P of A and B over P of B. So that's a formula we introduced last lesson. This formula, along with the formula that is true for independent events, that P of A equals P of A given B, can be used together to find a test for another test for independent events. So if I take these two formulas, those form a system of equations. Right? We have two true statements, two equations. And I can substitute this in for P of A given B. Now this is only true with independent events. This isn't all the time. So I'm going to write that new formula out. So that gives me P of A equals P of A and B over P of B. And then if I just rewrite this in a different way, if I multiply both sides by P of B, I get, I'm going to rewrite those in the other order, just have the formula, P of A times P of B equals P of A and B. Okay, so if two events are independent, it's also true, in addition to my conditional probability test, that P of A times P of B is equal to P of A and B. This is called the multiplication rule for independent events. This new formula can make sense visually, so we're going to look at the general probability table. We've used in the last 2 lessons, but we only are going to fill out certain cells so we can see it. So we know if we have conditional probability that if I go this way, actually no, I'm going to go just to show it works both ways. So if I find P of A, right, I would do P of A over 1, okay, or just P of A. And that, with that symmetry, has to be equal to P of A given B. So if we're doing given B, right, we're just in this column, so we have P of A and B over P of B. And we could see if we cross multiply or multiply by P of B, we get that multiplication rule for independent events. So you will see both of these on your reference sheet, those 2 tests. And we're going to go back, I'm just going to do one, just do the top problem for this video, but we can see that this will work on the 2 problems we already did. So over here, this is testing that multiplication rule for independent events. I'm going to write here. So in this problem, we found the events were not independent. So we're expecting this not to work. So P of A here, and I'll erase this stuff that's already there. We have what's going on. P of A, this B, we call this A. So it doesn't matter if I use different letters like, I don't know, G and H, that would be fine. We're going to multiply the probability of the 2 things. So P of A is 0.636, technically over 1, but I don't have to write that. If it was a number there, I would have to write a different number. P of B is 0. I don't need to write that multiplication symbol. Let's get rid of that. So this is times 0.333. And does that equal P of A and B, which is 0.226, once again over 1. So looking at this, if I multiply those 2 together, I get 0.212, and I see that is not equal to 0.226. Okay, so we can see that it doesn't work. I'm going to just talk about something on the last page that is super important when we do this. And I think I should do this one. I said I wasn't going to, but I am going to do that in the video. So if I try that multiplication rule for independent events here, I would be doing P of K times P of E equals P of K and E, or intersect E. Be careful, P of K is not 700. That worked that I could just take that number, right, because the other table had probabilities in it. That's 700 over 1,000. P of E is 800 over 1,000. And P of K and E is 560 over 1,000. If I type this in, I do get 0.56. And we see that the independence check, we found these 2 events were independent, does hold up.